Hello, here's another video on smart contract security, and this is episode 6, and I want to talk about front running. Now, front running is sort of a race condition scenario that I always thought of as sort of a theoretical vulnerability, but in fact there are many examples where this has been exploited in the real world, and it is something we have to worry about much more than I originally thought myself. But anyway, let's just first look at what front running is. And to understand front running, we have to look at how transactions are included in the blockchain. So the blockchain has something called the mempool, which is sort of the list of all unconfirmed transactions, which is just there waiting within the network. And the miners choose transactions from the mempool to include them in transactions, and depending on how the network is going, how busy it is, the transaction can be in the mempool for quite a while. In Bitcoin, they can be, the block time is about 10 minutes. So even if the network is not busy, they can be up to 10 minutes or more within the mempool. And in Ethereum, it's about 15 seconds, which is in computing terms is quite a long time. Anyway, when transactions are in the mempool, they are visible for the whole network. Any participant can see the transaction and can pre-compute the result of the transaction and knows what is going on there. And this can be an issue in things like trading, for example, because there's a time where unconfirmed orders are visible on the blockchain, and they obviously will affect the price, and people are aware of what is going to happen in advance and can exploit this. So basically, as I said, transactions are chosen one by one by the miner that proceeds the next block. Obviously, the miner is also chosen in a more or less random way, weighted by some computing power issue. But anyway, there's each miner has an algorithm in which he chooses these transactions, and that's usually based on how profitable it is for the miner to include this transaction. If the gas price is higher in a transaction, then the transaction will usually be processed first. And that's how you can actually overtake transactions in the mempool. So there is an attack where you see a transaction happening, know what's going on there, and you just overtake that by providing a better gas price. And the miners will prioritize your transaction. And when your transaction is included in the blockchain first, you can have an advantage depending on the situation. And that's basically what front running means. You overtake a transaction, usually by improving the conditions for the miner, incentivizing the miner to include the transaction before the other one. Here's just a very silly code example on how this could be exploited. It's deliberately simple, and there's a number of things wrong with this, but let's just focus on the front running issue here. It's a very naive lottery. Basically, the way this works, to play the game, to participate in the lottery, users can submit a large number, and then the contract computes the hash of this number, and if that hash is larger than a certain value, the parameter which is the difficulty, then the user that has executed this transaction is the winner and receives the balance of the smart contract. Otherwise, the transaction fails. Now, obviously, as I said, there are a number of things wrong with this, but one of the problems here is front running. So you can actually see this transaction on the network or in the mempool before it is included in a block, and if there is a winner, you can actually see that, and then you can just use that number, submit it yourself, and overtake this transaction and claim the winnings for yourself. Now, obviously, as I said, it's a silly example. It's really simple in order to fit it into a very small piece of code. But there are real-world examples of this being exploited. And in fact, one of the biggest cases is the actual ERC20 standard. In the official version, it has this vulnerability. There's an approve method which allows users or accounts to delegate transfer rights for a certain amount of Ether to other addresses. So you can basically approve an address to spend X Y of your account balance. And the way this can be exploited in this case is by Frontrunning or Frontrunning, or whatever you want to call it, a race condition in this case, probably better name. Imagine a situation where user A approves user B to spend 100 ETH on their behalf, but then sort of changes his mind and changes to 50 and just uses the approve method again. So if user B actually watches the mempool and sees this, it can quickly overtake this change to 50 transaction, spend 100 using the transfer from function, and then spend another 50 once this transaction has gone through. So instead of spending a maximum of 100 that was approved as one stage and then changed to 50, the user B has actually managed to get a hold of 150 ETH in this case. And that's because, given this ERC20 vulnerability, the user can basically get up to the sum of the two approve invocations. And there's obviously ways to avoid this, which I'll talk about in a bit. But it's interesting because these sort of race condition front-running issues are not that obvious, and even in the definition of the ERC20 standard, they sort of missed this one, and the current fix, if you have an old implementation that is vulnerable to this, or if you just use approve and transfer from directly, is to always set to 0 and wait for that transaction to go through before changing to another value. So if you already approved someone and want to reduce that or change it to a different value, you actually have to do approve 0 to revoke approval rights before you make the next invocation. And there's also current implementations of ERC20 usually have increase or decrease approval method, which is a safe way of changing the amount of approved spending. But anyway, interesting case, that one. And also the Banca liquidity network, which is sort of a decentralized way of exchanging funds, had an exploitable front-running issue in one of the earlier versions of the contracts, and that's been fixed now. I don't want to go into too much details in that one. But anyway, there's a number of best practices and things we can do to prevent these issues, but in general, front-running and race conditions is sort of built into the blockchain. There are a number of things you can do, but it's unavoidable that these transactions are visible. So the first thing we have to do is to actually be aware that all transactions are visible, and not just for front-running issues. For any type of privacy, we have to take this into account. And we have to think what happens when the transaction order is changed in any way. and think about potential impacts and variations of the flow of what we want to achieve with our smart contracts. One thing we can do, which is a bit complicated and not my preferred way of dealing with this, is to place an upper bound on the gas price within the smart contract logic. It basically means that you stop certain methods to be invoked with the gas price too high so that they could overtake other methods. But that always seems a bit contrived to me. And anyway, there's no guarantee which algorithm a particular miner will use anyway. I don't know, it's a bit too complex for my liking. Quite a common scenario is a commit and reveal scheme for supplying data to a smart contract. And that basically means that in one transaction you commit a hashed value of the data, and then in another separate transaction you reveal what that value was, and obviously that value has to match what you committed before, and that can be verified with the hash value, calculating the hash value obviously. So that way you don't reveal the actual number until after the transaction has been included in the block, the commit transaction. And that basically means that anyone reading the transaction cannot front run you, because it doesn't know what the information actually is. And that's quite common, and it's often used in sort of trading scenario, random number generation scenarios, gaming on the blockchain, and it works quite well. But anyway, transaction ordering, front running, and race conditions are very complex and something to be aware of, and certainly spend a lot of time thinking about. And as always, I'll end this video with a call to reminding you to get your smart contracts audited. We certainly look a lot at race conditions and front running when we do our smart contract audits. Anyway, that's all for now. I'll be back soon with another video.